Hello everybody and welcome back to Unit 9 of Regents Chemistry where we are talking about solutions. Today we'll be talking about how to determine concentration of a given solution, and the two units of concentration that we'll be using are molarity and parts per million. So concentration is the amount of solute in a solution, and remember solute is the substance that we have in a smaller amount in a solution, and then solvent is the substance that we have in the larger amount in a solution. So table T is where we can find the equations for both molarity and parts per million, and these are the two units that we use to describe concentration. Let's start by talking about molarity. So molarity is very specifically the number of moles of solute that we have in 1 liter of solution. And this is basically what the equation of molarity says as well. This is what you guys are given in table T. Molarity is equal to the moles of solute divided by the liters of solution. Now please take care of what we have on the top and what we have at the bottom. At the top, we are talking about the moles of solute specifically, not the moles of solvent, not the moles of solution. At the bottom, we have the liters of solution, not the liters of solute and not the liters of solvent. So take care of that. Now, when we're using this equation, there are a couple things that we want to take care of and be aware of. The first thing is when you're given the question, sometimes you might not be given the number of moles. In fact, you might be given the amount of that substance in grams. In that case, you guys do already know this from the stoichiometry chapter where we were talking about the mole calculations, how to convert the moles of a substance into, how to convert the mass of a substance given in grams into its moles. We use this equation right here, which is also given in table T. We take the given mass and we divide that by the gram formula mass of that substance. So let's say your solute is sodium chloride, which is table salt. Instead of giving the moles, the question gave you the grams of sodium chloride. So you'll put those grams at the top and you'll divide that by the gram formula mass of sodium chloride, and that should give you the number of moles that you can then use in this equation. And then sometimes, instead of giving the liters of the solution, the question might give you the volume in milliliters. So in that case, we'll have to convert the milliliters into liters. And the conversion factor for that is 1 liter has 1000 milliliters. Now let's practice with some problems. Here's the first question. If you have 50 moles of a solute in 25 liters of a solution, what is the molarity? You are given the moles of solute, 50 moles, and you are given the liters of solution, 25 liters. Pretty easy, pretty simple. All you have to do is plug this into the equation. So we start off by writing the equation, which is molarity equals to moles of solute divided by liters of solution. Once again, you have this equation given in table T. And then we just plug in the numbers. We've got 50 moles of solute and 25 liters of solution. Do the math, we get 2 moles per liter. Now, super important thing. Moles per liter is the unit for molarity. However, there's also a shorter way to write that, which is this. Moles per liter is just equal to a molar. And that, always remember, that has to be represented by an uppercase M. Please do not ever use a lowercase m. So that uppercase M represents molar. In the second question, we have how many moles of solute are contained in 200 milliliters of a 1 molar solution. Now here, we are given the volume of solution, which is 200 milliliters, and we are given the molarity of the solution, which is 1 molar. What we have to find out in this question is the number of moles of the solute. So, first things first, we'll write our equation, and then notice how our volume is given in milliliters. So let's fix that first. We'll convert those milliliters into liters. So we'll take the 200 milliliters and we'll multiply that with the conversion factor. We said 1 liter has 1000 milliliter. Remember, we want our answer in liters. So we'll put 1 liter at the top and then 1000 milliliter at the bottom. The milliliters cancel out. You do your math, 200 divided by 1000, we get 0.2 liters. So now we can go ahead and plug in the numbers in our equation. So we plug in the molarity of 1 molar, and then we plug in the volume of 0.2 liters, which we just calculated. Now we can do the cross multiplication to rearrange the equation and find the moles of solute. After we do the cross multiplication, we get this. Moles of solute are equal to 1 molar times 0.2 liter. Now notice how I have changed or substituted the unit molar with the other way to write it. So the uppercase M is also equal to moles per liter. So that's what I wrote there, moles per liter. That way we can cancel out the liter with the liter. And so when we do the math, 1 times 0.2, we get 0.2 moles of this solute as our final answer. Here's another type of question that you can get for molarity. How many grams of sodium chloride would you need for a 0.5 molar solution? So you're given the molarity of the solution, which is 0.5, and then you have to find the grams of sodium chloride. Now notice how in this question you're not given the volume of the solution, which is something that we do need for molarity. So whenever you are given, we are talking about a solution and the final volume of the solution is not given, we just assume that it's 1 liter. Okay, so as always, let's start by writing our equation. Molarity equals moles of solute divided by liters of solution. Now notice how in this equation we don't see the grams of solute anywhere. However, what we do see is the moles of solute. So if we calculate the moles of solute, it would then be easier for us to go ahead and convert the moles of that solute into the grams of the solute. So let's do that. Let's plug in the numbers. We've got molarity of 0.5 molars and volume of 1 liter. We'll do the cross multiplication. That way we get the moles of sodium chloride on one side and we get 0.5. Remember, molar is equal to moles per liter times 1 liter. Liters cancel out. And then we just do the math. We get 0.5 moles of sodium chloride. And now, to convert these moles of sodium chloride into the mass of sodium chloride, we can go ahead and multiply this with the molar mass of sodium chloride. So remember, this is how we calculate the molar mass. We have the mass of sodium is 23. We have 1 sodium atom in this formula. So 23 times 1 plus, same thing for chlorine. The mass of chlorine is 35.5 and we have 1 atom for chlorine. So get your molar mass. And then we multiply that over here with our number of moles. So we have 58.5 grams of sodium chloride in 1 mole of sodium chloride. The moles cancel out with the moles, and then we just do the math. 0.5 times 58.5 divided by 1. We get 29.25 grams of sodium chloride as our final answer. Okay, so now let's talk about the second unit for concentration that we were going to talk about, which is parts per million. So in theory, parts per million is basically just a unit of concentration that expresses the mass of a solute which is dissolved in 1 million parts of a solution. So this is what it means. Now let's say here we have the solution. And in the solution, all these circles that you guys see, the blue and the red particles, all of them are representing the particles of the solution. And let's say we have 1 million of them. Now, all of these particles are the particles of a solvent. There's only 1 particle of solute in there that we have added. So you've got 1 particle of your solute in 1 million particles of the solution overall. That's what we call a part per million. This solution is going to have a concentration of 1 part per million. If let's say you add 2 of those particles, we are going to have a concentration of 2 part per million for that solution. So that's basically what parts per million is. Now, as I mentioned before, the equation to calculate parts per million is also given in table T, and this is what the equation looks like. You take the mass of your solute and you divide that by the mass of the solution times by 1 million because it's parts per million. Now, some of the things to take care of here, super important things. First, notice how at the bottom we have the mass in grams of the solution. It's not the mass of the solvent. It's not the mass of the solute only. It's the mass of the solution. So in some cases, the question might trick you and it will only give you the mass of the solute, which you put at the top, and then it gives you the mass of the solvent. It doesn't give you the mass of the solution. If that is the case, you are going to need to add the mass of your solute and the mass of solvent to get the mass of solution. You cannot just use the mass of solvent at the bottom because that's going to give you the wrong answer, and that's not what the concept of parts per million is. We are talking about the mass of solute in the solution overall. So another thing that might happen is that sometimes the question might give you the parts per million, and so in that case you'll either have to calculate the mass of the solute or the mass of the solution. So to do that, you can just divide your numbers by 1 million. And we'll see that in practice in just a little bit. So let's look at some questions. So here's the first question. We have a copper sulfate solution which has 0.05 grams of copper sulfate and 1000 grams of the solution. What is the concentration in parts per million? So we'll do the first things first. Write our equation, which we just copied down from table T. Next, we can go ahead and plug in our numbers. The mass of solute is 0.05 grams and the mass of the solution is 1000 grams. Everything is given straightforward here. There's nothing that we need to figure out. And then we time that by 1 million. Just do the math, plug everything in your calculator, and your answer turns out to be 50 parts per million. Here's another question. What are the parts per million if a solution contains 75 grams of solute and 150 grams of solution? We are given the mass of the solute and we are given the mass of the solution. Once again, everything is pretty simple. We start off by writing the equation, copy this down from table T, and then plug in the numbers. The mass of solute is 75 grams, the mass of solution is 150 grams, and then we time that by 1 million. Now when you do the math, this is what you get. And the reason why I included this question here is because if you get a larger number like that, you would want to convert that into scientific notation and write your final answer in scientific notation. So remember the rules. We want, whenever we are writing something in scientific notation, we want our decimal to be right after the first non-zero digit. So in this case, we want the decimal to be right after 5, which means we'll move that 5 times to the left. So when we move the decimal 5 times to the left, we get a positive exponent. So in this case, the final answer will be 5 times 10 to the power of 5 parts per million. Now this is the type of question that I was talking about earlier. Here we are given the parts per million of the solution and we are given the amount of solution and we have to calculate the grams of the solute. So in this case, once again, we'll start off by writing the equation and then we'll just plug in the numbers. So right now we are given 3 parts per million and we are given 150 grams as the mass of the solution. The next thing that we want to do is rearrange this equation so we can calculate the mass of the solute. And to do that, we can do the cross multiplication. So here we have, to find the mass of solute, we'll do the cross multiplication by multiplying the 3 parts per million with 150 grams. So that goes at the top. And then we'll take this 1 million that we have on that side, and we'll multiply that by the 1 at the bottom, and that gives us 1 million that we are dividing with the other number because we are bringing this to the other side. And so now on one side we have the mass of solute, on the other side we have those two numbers divided by 1 million. Now let's just do the math. This is what we get. And notice how this is a super small number. So that means we can write this in scientific notation as well. So this time we'll have to move our decimal. We want our decimal to be between 4 and 5, right after the first non-zero digit, which is 4. So that means we'll have to move it 4 times to the right. So whenever the decimal is moved to the right, we get a negative exponent. So that gives us 4.5 times 10 to the power of negative 4 grams of solute. Alrighty guys, that was it for this part of the unit. Keep practicing. Happy learning. Take care. I'll see you in the next one.